questions. Okay, so we're gonna get to that. But prior to that, I'd like to just to cover something, to first of all get some question from you, okay, to see if we have any questions, any you know, especially for those of you who did not take trigonometry, okay, and I promised you that I would do something with about this unit circle, right? And I did do that with my other class, and I think I will make that if we have other questions, I will answer your other question. But for this one, you either watch the recording from my other class, or if you have, or I can go over this just a little bit, So do you guys have any questions? Any questions? I have made all the quizzes, the answers to those quizzes and your responses to the quizzes in the past from number 1 to number 10 available to you. And I apologize for this delay, but it's mainly because there are multiple reasons. It's not I have forgotten. I have not forgotten. I was just debating. There's some special circumstances that how I'm going to accommodate those situations. So as we have come to this point, I think I would just need to take care of the majority of the students in our classes to because it's a very good practice for you guys to, after the quiz, you know, you get to see the answers and your own responses and find out what's wrong, what you have done wrong. And quiz number 12 is available today at 2 p.m. and you're gonna have the whole weekend. So this will mainly cover the homework questions that we have assigned for this week and the last. Okay, it's primarily about ARD. Okay, so do you have any questions here? Excuse me. Any questions? No questions?
Professor, it's not really related to the class, but I wanted to ask if you take attendance.
I do not need to take attendance because every day the Zoom will automatically record your time of entry and time and exit.
Okay.
Yeah, so that I will have those files and available.
My computer crashed for like a few days and I didn't like enter class. So I wanted to know if that like affected my grades or not.
No, your attendance usually does not affect your grade.
Okay.
You just miss the part that the live interactions in class, provided that you're going to watch the recording.
Yeah, I watched the recordings.
Yeah, so
thank you.
Yeah, of course, it doesn't affect. Okay, and so your grades will be determined not by attendance, but by, you know, how well you perform on the quizzes and exams. All right. So without further ado, and I think we have covered up to cotangent, right? So ideally, I would like to move towards the inverse function, but I do want to fill out some gaps. I like to fill out some gaps, especially we have people in this room that has not done trigonometry, right? And knowing that this class is from you know, it's 5 classes in one. So first, before we do the unit circle, right? Before we do the unit circle, I just want to get some response from you. How many of you want me to cover this unit circle and how this number has come about? If none of you wish that to be covered, and then I will leave you to watch the recording. Okay, I will post that recording from the other class anyway. So yes, so is that Angelica means that you want that to be covered in this class? Okay, so I would do it for you as I did it with the other class. Okay, because this class time is a little shorter than the other class, so I'm going to borrow some pictures from the other class. Okay, so just 1 second, just 1 second. I'm going to borrow some pictures from the other class, so that way we can go a little bit faster. And so that's today. Okay, so I'm going to borrow some pictures from that class. Okay, so we start from this one. Okay, we can start from that one. So close here. All right. Whether you have done, whether you know where this came from or not, you know we have been using this a lot. You know we have been using this a lot. Do I expect you to remember all these numbers? No, I don't. I mean, you don't really need to. You don't really need to. But today I will give you a better reason why you don't need to, right? So we understand the geometry. When you were doing geometry, you did not need to do the rectangular system. But I also mentioned to you that the trigonometry is digitized geometry. Digitized geometry. Except that this was done hundreds of years ago by mathematicians, long before the digital age that we are in today. Okay, so how is it being digitized? Let's see how it's been digitized, right? So first of all, you see that all these are special angles. All these are special angles. But I want to do this pretending we don't know this. Pretend we don't know this, okay? So now we pretend we're making that triangle. We're making it. Okay, so what do? We're going to start from the beginning, right? We start from the beginning. We know that we need to use ARD, right? So ARD. From ARD, right? A is the angle measurement. R is the what? The reference angle, the positive acute angle between the terminal and the x-axis. And D is the definition. D is the definition, right? So when we are making these, when we are, getting to this terminal is measured. Okay, so I'm going to use a green, which is a color. I think it's neither, this is the standard position. We know that there's a green. The thick line is the standard position we're all familiar with. So from this position, we measure pi over 6. Pi over 6 is 30 degrees. So I'm going to mention both the radians and the degrees. The purpose that you're going to quickly do that transition, okay? You use it often, and eventually towards the end of the semester, or maybe even sooner, that you will know those angles. You know those angles, okay, by radians, right? So we have talked about those importance in the graphing. But anyway, so we make this angle. This angle is 30 degrees, which is pi over 6. Pi over 6, right? So I'm going to write it down here. This is a pi over 6. Okay, pi over 6. With pi over 6, we want to, this is the terminal, right? This is the terminal. So by definition, we want to identify a point on the terminal side of the angle, right? So this point I chose to be x comma y, x comma y. Okay, x comma y. What is x comma y? Well, they all have meanings, right? They all have meanings. So the blue, right? This is the blue. This is a y. Oh, oops. I want the blue. Come on, give me the blue. Okay, so this is the y. Okay, this is how high is y. And this is the red. So x is the red, y is the blue. If we can determine the x value and y value, then we get the coordinate. And this terminal is in the first quadrant. Therefore, as long as we can find the x value, x is positive, y is positive, then we got the sine and cosine, right? Then we can apply the definition. We get sine, cosine, tangent, cotangent, secant, cosecant, and so on and so forth, right? So that's the story. Now, how do we find out these values? Okay, this is how we find the values. We're going to have the triangle flip over, like you have a mirror image along the red. The mirror image along the red. If we have that mirror image along the red, what are we getting? We're getting that piece because that green is reflected on the red. And we have another piece of blue, right? So the blue and blue are identical. The blue and blue are identical. So if this is 90 degree, I'm sorry, 30 degree, okay, if this angle is 30 degree, and we have two 30 degrees here. So this angle entirely is 60 degree, right? So if you look at this big triangle, this is 60 degree, and that's 60 degree, and that is 60 degree. Any questions? So we have three angles with the same degree. So their respective three sides are the same. So this side is 1, this side is 1, and this side is 1. So what will happen to the blue? And the blue side, this half of blue is going to be half. And this part, this other blue is also half. And the diagonal, no, I'm sorry, the hypotenuse is 1 because this is on unit circle. So this is 1, this is half, and the red is to be found. So we already know the blue, right? This half is equals to y, right? We just need to find out what will be the value for the red. And the red, of course, we know is equals to x. So this piece is x. So using Pythagorean theorem, okay, we will get, what do we get? We'll get x squared plus, okay, half squared. Okay, half squared. That actually equals to 1 squared. Pythagorean theorem. Okay, I'm sorry, this is shifted, but you can still see the numbers, right? Okay, so one leg, the other leg, and the hypotenuse. So x squared plus half squared equals to 1 squared. So we're going to solve for x. We're going to solve for this x here. Okay, so now I'm going to clean this up and show you the method, the algebraic part. Okay, showing you the algebraic part. We'll come back. Okay, so from Pythagorean theorem, we got this. What do? Well, we just have to do the math. Everybody, do you have your paper pencil with you? Do you have your paper pencil with you? Let's work this out to get x. You there? Okay, so we get x squared plus half squared is a quarter, right? And 1 squared is 1. Okay, and we're going to subtract 1/4 on both sides. We're going to subtract 1/4 on both sides. So it's 1 minus a quarter. What is 1 minus a quarter? You're going to find common denominator. 4/4. 4/4 is 1 minus a quarter. And that equals to, we have the same denominator now, so the same denominator is capital 4 minus 1 is 3. So eventually we got x squared equals to 3/4. And then what do we do? What do you propose we do? Good job, Harrison. We'll take square root on both sides, right? Because our goal is to find the value of x, not x squared. So we take square root on both sides. We'll take square root on both sides. And what do we get? What do we get on the left-hand side? What do we get on the left-hand side?
We would just get x.
You think so? Does everybody agree? Do we just get x on the left-hand side?
Yes, because the square root cancels out the 2.
You guys are still doing that, huh? You guys still doing that?
Is it plus or minus x?
Ah, we have all these answers. You're telling me
Would it be the absolute value of x?
anybody has any confidence about what you're doing here? Hmm? We talked about these before, didn't we? Do we have a D?
B?
Do we have a D?
I don't think so.
All right, but just in case anybody come up with a D. Number one mistake according to the author of calculus, right? Yes? Yeah? I'm going to show you a way to show work so that you always get all the points. You leave no room for your professor to deduct point from you. Okay, so don't do that. Don't do that. Don't do that. Okay? Number one mistake, right? We talk about, so go back to listen to the lectures when we were doing, I think week 2. I'm glad I hear this answer. This answer is not as popular, but I have a real story to tell you. Okay. As a full-time faculty, I was once, selected to be on a hiring committee. Hiring committee, you understand what that means, right? We're hiring new people to be on the faculty. And this guy who came to interview, he was a PhD. He got a doctorate in mathematics. At the interview, we asked this question. What's the square root of x squared? Under the interview, and this doctor so-and-so, he said that's equals to plus minus x. Guess what? He did not get that job because of this mistake. You follow me? I want you guys to remember that's a terrible, horrible mistake wherever you learn it. Wherever you learn it. Okay. It violates the function definition and is not, you have a counter examples left and right waiting for you. Okay, you just plug in x equals to 1. Is that going to be true? Square root of 1 squared equals to plus minus 1. How is that a true statement? How is that a true statement? I was telling this story is that this cost someone a job. That's how serious that mistake is. Okay, that's how serious that mistake is. All right. So, any questions? Now you understand why we talk about this at the very beginning of the semester, right? This is very common mistake. You can see after we have addressed these issues, we still have people making these mistakes. Terrible mistake. You're guaranteed to lose a point or two. You're guaranteed to lose a point or two. So what is the bulletproof way of doing it? Okay, I'm going to show you the bulletproof way to do it. Okay, so whenever you encounter the square root of x squared, it should be equals to x. I also just heard someone says, okay, someone says this. Okay, someone said this. Say, I'm going, so this is a square root 2, and this is the square root of 2. Okay, you learned somewhere, your professor told you this 2 and that 2 canceled, right? Yes? That's what you learned. One of the professor taught you, one of the teachers you had before taught you. You can only do that if x is non-negative. Okay? And whoever taught it this way, without emphasizing that condition, and x has to be non-negative, is responsible for whatever, but you're going to bear the consequence of whatever that mistake. You guys follow me? If you really like that convenience, okay, that convenience only works for odd number roots. It doesn't always work for even number roots, right? It works for root 3. If you have root 3, x raised to the power 3, that would be true. Okay. So it doesn't work all the time. So I don't know where you learn it, but wherever you learn it, okay? If you don't specify what x is, you cannot do it. In this case, x can be any real number. You guys follow me? And of course you say, yeah, x is in the first quadrant. You could have done that, but you leave some doubt in your professor when they're grading. And the professor may think, is this student making that mistake? If you don't want your professor to have any doubt about what you know, what you don't know, I recommend you adopt the way I'm doing it here. Because you want to get points from those professors, right? Don't you? Yeah, otherwise, why do you come to school? But these things I'm addressing, they're very, very common mistake. I see this mistake all the time, every time -2. Every time -2. Do you hear me? You might get lucky. Some professors just give you -1 point. I would just -2. Does that get your attention? But every math professor should know that's a mistake. And calculus author, the author of the most popular calculus textbook named this #1 mistake. Think about that. Think about that. Okay, so now I'm showing you the bulletproof. Okay, so now if you really want to do that, right? You learn that this is so convenient. I'm just cancel this 2 and 2, and this doomed to get you lose 2 points. You can only do that if it's an odd number. It could be 6, right? It could be 6 here, then you end up with an x squared. Okay? Only with odd number roots, you can do that reduction. With even number roots, no. Absolutely not. Did what I said get to your ears, your mind? Yes? Very, very bad mistake. Anyway, without further ado, I promise you, I'm showing you the bulletproof way to show the work. Right? So what you do on this side, the square root of x squared equals to absolute value of x. You just do that systematically. And then you take care of the rest. Okay, I'm going to show you how to take care of the rest. So this tells you the absolute value of x is √3/2. Therefore, x could be what? Could be positive or negative √3/2. And then here comes your argument. Here comes your argument. Because the angle we measured is pi/6. Because the angle we measured is pi/6. Therefore, okay, then you need to tell the reader, okay, because why do we need to have these accessories? Because as your teacher, okay, as whoever teach the class, we need to assess whether you understand the material. So not only we teach you, we also assess whether you got it. So between the lines, we are assessing you constantly. Constantly. We assess if you understand the whole thing. If you want to cut corners here and there, then it makes the assessment very, very difficult or impossible. So you just have to lose points left and right, because there will be someone else in that class, and some other people in that class, and those students would do perfect job. So what do we do as professor? Do you guys understand what I'm saying? Everybody is graded the same way with the same criteria. All right, I hope you guys really just get it. Okay, I know this work I'm showing you doesn't look very short, but it's a bulletproof way to get you the points. Okay, so this is a statement. Because the angle pi/6 terminates in first quadrant, in quadrant 1. What does that imply? That implies x is positive and y is positive. And thus, you can say x is equals to positive √3/2. You can cut some stuff in between, but that mistake is definitely going to get you professor's attention. The professor will have a question mark on his or her head, in her mind. Is that, does he or she really know that? Okay, so that will give him good reason to deduct a point or two. Okay, I hope I have made that very, very clear. Okay, because we have a part of our job description is assess your learning. But anyway, so this point, so what is this point? This point is √3/2, comma, 1/2. Okay, and what are those? The red is √3/2, and the blue is 1/2. So so what we did at the algebraic, and that's the visual. That's the visual. Okay, that's the visual. So now let's look at another scenario. Okay, the next scenario is that I'm going to measure the angle, but it terminates at 5π/6. Terminate at 5π/6. Okay, you guys with me? So I'm going to borrow another picture from my other class. You know, I'm going to do a little less than I did with the other class. So I'm going to use this one. There. Okay, so this is one scenario. Okay, so let me give you another scenario. Another scenario is that I'm also measuring from the standard for position. That's A. I'm doing my A. Okay, so I'm not going to use this color. I'm going to use a green. Okay, so I'm measuring my other angle. The other angle could be measured, you know, counterclockwise. I get 7π/6, or I could measure clockwise, right? Still ends up here. And I can do it around and round and round, still end up here. You guys follow me? It doesn't matter what angle you're getting, but that angle terminates in the third quadrant. Okay, so now I terminate here. Doesn't matter which angle. Right? You guys fully experienced this in quiz number 10, didn't you? That was the intention. If you go back to look at quiz number 10, the description is you are told the terminal, the angle terminates there. So what are the angles that will terminate there? That angle can be as many as you wish. Okay, so without further ado, so what are we trying to find? We try to find x comma y. And what is x? And what is y? Right? So the y would be this. Okay, I'm sorry. The y is this guy, right? The vertical. And what is the x? The x is this guy. In this case, because it terminates in the third quadrant, so x is negative, y is negative, right? So how do we find the value for x and y if this terminal, suppose that is a 7π/6, 7π/6. The reference angle kicks in, right? What is the reference angle? That's the reference angle. Okay, and the reference angle is what? What is it? π/6. The reference angle is the positive acute angle between the terminal and x-axis? Pi over 6. So how do we find the length of the red? And how do we find the length of green? So from what we have done here, because the terminal in the third quadrant, so x is negative, y is negative. Right? If you look at that unit circle I sent it to you, you guys know that these two are going to be negative numbers. But how do we find them? Right? This is what this class, this is what we try to cover. And what do? We're going to do the same thing. We're going to have the mirror image of this right triangle over to the top. Okay, so I'm drawing a identical line. I'm going to reflect this triangle over the red line. Okay, over the red line. So here. Okay. Sorry, this is not long enough. You guys follow me? So we got a similar situation as we did last time. So this is pi over 6. And now this angle, the double pi over 6 is pi over 3. So this is pi over 3, pi over 3, pi over 3. So 60 degrees, 60 degrees, 60 degrees. So this is a unilateral triangle. Once again, so the three sides are the same. So this side is 1, so this side is 1, and this side is also 1. And because the way we construct it, once again, this is a half, and that is a half. Right? So do we know why now? So y is equals to what? The digitized situation, this y is a negative half. Do you guys follow me? And the hypotenuse is 1. So can we find the red? Can we find the red? Can we find the red? Sure, Pythagorean theorem. Pythagorean theorem. Okay, so let's see how we set up. How do we set up? Right? X is the red, so x squared, that's one of the legs. So x squared plus negative half squared equals to 1 squared, Pythagorean theorem. Here, whether you use a negative half or positive half, it doesn't make any difference because negative half squared is a quarter. Positive 1/2 is also a quarter. So this part is, it's no big deal, but you need to be aware that the digitized situation, y is a negative half because it's underneath y-axis, underneath the x-axis. Do you guys see that? And then this whole thing looks familiar, right? So it's going to be x squared plus quarter equals to 1. Okay, this is going to be x squared plus a quarter equals to 1. Did you guys write this down? I'm going to move down and show you the algebraic part. You ready? So now I'm going to clean this up. Okay, clean all drawings. You guys get it, right? So I'm going to solve this equation for x. Okay, but when I do the work, I'm showing you the bulletproof work to be done to ensure all points you deserve. Okay, so that's going to be 3/4. Oh, sorry, 3/4. Okay, and then I'm going to take square root. I'm going to take a square root. You guys need to remember that the kind of work we're doing mathematics. Math is either true or false. False once false. It doesn't accommodate any mistake. We have to be absolutely rigorous. Now you understand we have to take absolute value. Okay, show that step to your professor, impress him or her. Okay? And then what? X is equal to plus minus root 3 over 2. Then you will say because A terminates in quadrant 3. What does that mean? X is negative. X is negative. X is negative. Therefore, your X should be what? Your X should be
Negative.
negative root 3 over 2. Okay? And what was Y? Y was negative. Well, remember, we're digitizing this whole geometry, especially on the right triangle part. So that's how these two numbers are in place in a unit circle, right? So that number is going to be how it's been marked. Negative root 3 over 2, comma, negative half. You follow me? Yes? Now look at the unit circle. Look at this one. What have we done? We have covered, right? We have covered when the terminal is here and the terminal is here. Okay, so for you, you may like to do these two, this one and that one. Right? Then you understand. So you really just need to know all of these numbers. Right now we will do the first one and they will just be flipping to the other 3 quadrants.
If she hop out, your bunny's gone. Like, what are you gonna do?
Okay? Do you guys follow me?
Yes.
Right? So you understand where these numbers come from. That's where it came from. Digitized geometry. Digitized geometry. So now let's look at this one. Terminal, which is pi over 4. Okay, and this time you guys are going to participate. Okay, is Farouz here? Is Farouz
Yes,
here?
Professor, yes.
Farouz is very eager to help all the time. Okay, so I'm going to have you guys do the second quadrant. How about that? Right, I'm going to have you guys do this. I'm going to move this terminal to the other side, to the second quadrant, and you guys are going to work that out. How about that? So this point is turned into that. I want you guys to do one more before we do the pi over 4. Okay, we do one more before you do one more. I want you guys to have the hands-on experience. So your job is to go through the process we just did. I assure you, this process, if you know how to do it, it's going to benefit you when you take calculus 1, calculus 2, maybe even calculus 3. You will encounter some of those stuff. Okay, you will. Okay, so we're going to try to identify the points over here, x comma y, right? And we know that this is going to be the y, right? Y is positive, right? You've seen that. And you're also going to identify the x. But x here is negative. So I want you guys to start from Pythagorean theorem. Draw these lines by your own hands on your paper. And that will do miracles to your subconscious, your subconscious level. And you will understand the material better. So don't just watch, okay? How many people are getting paid by watching someone play basketball at NFL? None, you pay them, right? You pay the stadium, or you have to subscribe to TV network. Who's getting paid? The people who play the basketball, right? To get their hands on it. So you want to get paid. Of course, your payment is much less than those stars, but you want to get paid by degrees, right? And in the future career, don't you? So do it by your own hands, okay? So I'm going to start a breakout room. You guys know what to do, right? Because I want you guys to mark these 2 points. Mark this point with x, y, go through the Pythagorean theorem and do the bulletproof steps. If you want to, I'm opening the breakout rooms, but Farouz will be around. He will watch who's in the room, who's not in the room. He will go there to help. And I'm going to give you a couple minutes to work on this, okay? Maybe 5 minutes. Okay, I'm going to step out just for a few minutes. Okay, I'll be right back.
Professor, I can also help the students right here in main room, then breakout room, while
Okay.
you're
Yeah, yeah, I'm just going to be stepping out for a couple minutes. I'll be right back.
Okay.
Thank you, Farouz.
You're welcome. Okay, I have my board. I don't know if anybody has question, you can unmute and let's work it out together. Copy the same process Professor did on the previous steps. On the second quadrant, any suggestion? What should we do? I go with the beginning. So the unit circle, therefore the hypotenuse in this right triangle is how much? If it is a unit circle. Let's say R radius or hypotenuse is 1. The angle here is 30 degrees. So we want to see what are these values, x and y's. So this is the y value. And then x value here. So as you see, x is with respect to point of origin is 0, 0. With respect to point of origin, x is less than 0 or negative. The sign is negative. So we can write that, or we can write negative x. Y is still positive. It's above the x-axis, positive. So what the professor showed, right? As just extend this line here. And have our another triangle here, 30 degrees, makes it 60 degree here, 60 degrees there, 60 degrees there, unilateral triangle. And then, so if the radius are 1, how much would be the each blue part with respect to this right triangle here or this right triangle there? One half. So as soon as we get these values, we can go use the Pythagorean identity and get the values. So I go a little bit faster. X squared plus y squared equals r squared. R is 1. Y is 1/2 squared, and the x is x squared. So working it out, x squared plus 1/4 equals 1. X squared equals 3/4. And here again, professor stressed a lot, which is very important, how to square root both sides. If we square root both sides, what happens here is we have to write absolute value of x equals 3/4, 3, the square root of 3/4, or 3, the square root of 3/2. And then, since x is what? Negative, therefore our value is going to be what? X is going to be negative square root 3/2. Absolute value of x is root 3/2. And I have to write one more step here, plus minus, then analyzing because, right? Because x is negative, therefore x is going to be negative root 3/2. So here we bring the x here, negative root 3/2, and the y is 1/2. We get that point. So these are the steps, the way professor wants us to remember, especially this area, as she mentioned. Any question, let me know, unmute, or you can type it on chat. Otherwise, professor is here. Okay.
Thank you. I was here a little while already.
All right.
Thank you. Great job, Farouz. Right, there's a various way to do this, but what we're trying to show you is the bulletproof way of doing it. Right, we ensure that every step we do, we show you, and it's very well established, so you don't lose the points. Right, whether you do it or not, that's really just up to you, but you really need to understand, right? You really need to understand. There are always some student in my classes, in my past classes, they will do it, right? So you don't want, if you don't get those points, other people will. Okay, so we're done with this part, right? We're done with this part. Everybody got it? I don't need to do it again, right? All right. So next, let's look at the other angle, the pi/4 angle, right? So suppose that I'm going to measure this, the terminal is going to be in the, right? It's going to be in the first quadrant, but the terminal is on pi/4. Okay, so this terminal. right? And that's the point. And I'm going to add, I'm going to make some changes, right? So look at that. So that's your terminal, pi over 4. So you still measure, you still think in terms of ARD, right? You measure your angle. I'm not using red. I'm going to use the green, right? So I'm going to measure my angle. You can measure your angle. The input is from the standard position. I measure up to pi over 4. But I may also measure clockwise and ended up at pi over 4. You see what I mean? You have many angles. You can go around and round and round. You end up at pi over 4. Okay? And you can go around and round at, clockwise, and you end up with pi over 4. All of these angles, no matter, right? So that was what we're trying to instill in you, that one terminal corresponds to many angles. Okay, with that said and done, how do we identify the X and Y, right? How do we identify the X, Y as indicated in the definition? Definition, right? X comma Y, and we choose that point to be on the unit circle because it doesn't matter, the ratio will be the same. So what is X, right? So this is the Y. Oh, sorry. They changed the colors. Okay. So this is the Y. And this is X. XY, right? XY. Okay, so what is the angle? The angle is pi over 4. The angle is pi over 4. This angle is pi over 4. What's the degree for pi over 4? What's the degree for pi over 4?
Isn't it 45 degrees?
Perfect, that's right, 45 degrees, absolutely. So this is pi over 4. And this is a right triangle, isn't it? This is right triangle. If this is a 45 degree pi over 4, and what would be the other angle? This is 90 degree, right? So this is a 45 degree as well, right? Pi over 4. So we have pi over 4, pi over 4, pi over 2. With this observed, what kind of triangle is this? Isosceles, right? Isosceles, two sides are equal. So the blue equals to the red, and they're both positive in the first quadrant. So in this triangle, Pythagorean theorem applies because it's a right triangle. So what happens now? We will have x squared, we use Pythagorean theorem, plus y squared equals to 1 squared. 1 squared is 1. But x is the same as y, isn't it? So x equals to y, right? If x is equals to y, we can replace y by x, can we? Well, x by y, right? Doesn't matter. So that replacement will lead us to what? What does that lead us to? Once we find x, we found y, right? And now what? So you have 2 times x squared equals to 1. Everybody do it with me, please. Right? And then what you get? You divide both sides by x squared, by 2, right? So x squared will equal to what? Half. Right? And then what do? We take square root. We take square root. We take square root on both sides. You guys follow me? Okay. And then what do we got? I'm going to give you another, a slightly tweaked, a slightly different, alternative, okay, to show your work. The absolute value of x, and then we're working on square root of half. Square root of half is square root of 1 over square root of 2, right? Square root of 1 is 1. Square root of 2 is square root of 2. So this can be used as your answer, as you saw on the unit circle. Okay, this can be used as your answer. Look, the answer give you like that, right? But some people like to rationalize it. So we rationalize it. We multiply by 1 using principal number 1. And then we end up with root 2 over 2. So root 2 over 2 and 1 over root 2, these two numbers are what? They are identical. They just look different. They are identical. They're identical. They're the same number. They give you the same numerical value. It doesn't matter which one you show. Okay? So now, in the first quadrant, x is positive, y is positive. Therefore, the absolute value of a positive number is the same as the number. You guys remember this? Do you guys remember this? We spend so much time illustrate that, right? What did we try to illustrate? Oh my God, you guys need to get this. You must, because this will ensure you get points or you lose points. Okay? If x is positive, okay, I just want to take this opportunity to review this, right? If x is positive or equal to 0, the absolute value of x is the same as x. If x is negative, the absolute value of a negative number is its opposite. And of course, in this situation, x is positive, right? X is positive, therefore, right? But you need to tell the reader, because the angle A, whatever you call it, right? If you have a name for it, terminates in quadrant 1, right? We're talking about in quadrant 1. And what will happen? The absolute value of a positive number, right? So we know x is positive. So the absolute value of positive number is the same as the number. And that will lead us to x equals to root 2 over 2. Or if you like to use this number, that's not a problem as well. Either one, you can use either one. But this sentence, right, at the time we were addressing this in the first week. Was it first week or second week? Okay, either first week or second week. This is super duper important. You get to you have to even use it in calculus 2 when you're doing integration. Right, you're doing integration. Okay. They're just pop up here and there. And you cannot get away with this function. You cannot not see this function in calculus 1. Every calculus textbook has this function addressed because this function is that important. And if you don't master this function, you're guaranteed to lose some 20 points at least. Okay. So I hope I have given you enough warnings. I've given you enough warnings. So with that said and done, shall we practice another one? Shall we? So this time I'm going to make the 45 degrees on the second quadrant. Okay, with that reference angle. How about that? Okay, you try this. You try this. Okay. So with the one we just did, right? So we basically get these 2 points. The red and blue are the same numbers, right? We found red, we found the green, we found the blue. Blue is the same as the red. But what if they're on the second quadrant, right? So now it's your turn. So I'm gonna move the terminal to the second quadrant, okay? So just a second. Just a second. There. Okay, and you guys are going to do the algebraic, reflect on the definition, ARD, right? To identify the coordinates of this point. That is, you need to tell me what that point is. Okay, this point, X comma Y. This time X is negative, Y is a positive, right? X is negative, Y is positive. So you need to keep that in mind. This is digitization, okay? So are you ready to go? So that's the blue. Whoops. Come on, blue. Give me the blue. So this is the blue. It's a vertical line. And that's my red. Your main task is after you set up, you have to make sure you use the absolute value properly. You use the absolute value properly, okay? The ultimate test for you is that when you're in calculus classes, in chapter 2, chapter whatever, multiple chapters, you're going to encounter absolute value, right? And you can ace those. You can ace those. Now, ready, set, go. Ready, set, go. Go. And the angle, of course, I forgot to mention the angle. The angle is measured, you know, any way you wish, right? Counterclockwise, clockwise, go around and round. But anyway, you end up here. You end up here. And you just want to find X comma Y. Okay, the X is the red, the Y is the blue. Ready to go? I'm going to give you a couple minutes. Breakout room set up. If you stay with me, I'm just going to give you time for you to work it out for a couple minutes.
I see a student in breakout room. I go there.
The breakout room is open now. I will make the lecture this morning with my other class available to you guys as well. Because in that class, I did something slightly different. I did a little bit more in class. Okay, but there's some overlap. Okay. Because we don't have that much time. In that class, I have 2 hours. But your 2 hours is on Monday. Your 2 hours on Monday. But on Monday, we have other plans. Okay, we're gonna do inverse trig functions. All right, so I'm gonna catch up with you. Right, so now we cannot say x equals to y, but we know that x squared equals to y squared, right? X squared is y equals to y squared. Right, because they're the same length, okay? So you also get 2 times x squared equals to 1. And in the end, you get x equals to x squared equals to 1/2. And then you take square root, right? In the end, we get x equals to absolute value equals to 1/√2 or √2/2. Okay. Then you have a narrative because the angle terminates in quadrant 2. X is negative. X is negative. Doesn't mean X is negative. Well, what would that happen? What would that cause if X is negative? Well, we just talked about, right? This fact. This fact. Right? The absolute value, X is negative. So the absolute value of a negative number is its opposite. So that equals to √2/2. As a result, X is equals to what? Negative √2/2. Right? Or you can also use this point. You use this number. You can use either number, but what have we done? If you look at the unit circle we have here, if you look at the unit circle we had there, right? It's right here. We have just accomplished, right? We have just accomplished this terminal. Any angle terminates here. The XY are there. The blue number is a -1/√2. I'm sorry, the red number is -1/√2. The blue number is 1/√2. Positive sign, negative sign according to the quadrants. So this way you can do the 4th quadrant, 3rd quadrant, any quadrant you can do it, right? So I basically have given you the tools for this situation. Because this is 5 courses in one, when we assess you, we actually look through the steps, right? Look through the steps. And so you need to maintain those steps and make sure they are all sound and solid, sound, and solid. We're building a house on a rock, building a house on a rock. Okay, so last but not least, right? So we have done, what have we done? We have done all the 90 degree, all the pi over 6, right? Pi over 6 as reference angle, right? That's these. And we also have done pi over 4 as reference angle, right? Pi over 4 as reference angle. And now you say, how about pi over 3? Right? How about pi over 3? So let's look at pi over 3. Okay, so let me draw the picture so we can do that together. We can do that together. Okay, so I'm going to draw that picture. Right, so what I'm going to do is that I'm going to have that pi over 3 pi over 3. Oh, pi over 3. There, pi over 3. Right? It's pi over 3. Pi over 3. What degree is the pi over 3? What degree is pi over 3?
60 degrees.
Perfect. That's right. You are absolutely right. Right? So we still do ARD, right? ARD, I want you to do everything ARD. That's what I want you to do. Okay? So we measure pi over 3, right? And we could also measure it this way, clockwise. We end up here, right? And you could be doing this different circles a few times and still end up there, right? You get many angles ended up there, right? So with that reference angle, we know this is 60 degree. And what is X and Y? We know this is a Y, right? And what is X? This will be X. Right? So now we're doing the first quadrant. We're doing the first quadrant. We're doing the first quadrant. So this guy is 60 degree, and that's a 30 degree, pi over 6, pi over 3. So how do you find out the heights of the length of red and the length of blue? What do you do? What do you do? You do that all over again, right? Right? Mirror image of the current right triangle along the blue line. So this is 1, this is 1, this is 1, unilateral triangle. And the red is what? Is half. What will be the blue? Root 3 over 2, right? Root 3 over 2. So you can see the making of, so you really just use that two special triangles to get all those numbers, on the unit circle. Do you guys see that? I'm not going to cover the details here. You guys got it, right? You guys got it. If you do something in the fourth quadrant, I want you guys to do this to do it before we close the day. Okay, so give you another practice.
Professor,
Yes?
we came back from breakout room. I guess you're telling us about this pi over 3 angle.
Yeah, we're doing pi over 3 already. I'm sorry.
That's fine.
Did anybody miss this?
We jumped in the middle of explanation.
Okay, so let's do it again, right? So this time I'm going to give you a task. I want the terminal to be in the 4th quadrant. Okay, 4th quadrant. Okay, the 4th quadrant. And your job is to do this. 4th quadrant. And what you're going to do is you're going to identify the X and Y's in the definition. Are you guys with me? The blue and the red. We're not going to do breakout room. Okay. This is digitization, okay? X comma Y. Everybody doing it. I'm gonna give you 5 minutes. And I'm gonna have Farouz to share that with us. If you have a question, maybe in a couple of minutes, right? Farouz, using that board. Do you guys have Farouz presentation?
I had a few students, I mean, we had this class, we have many students participating
Good.
compared to previous class.
Right. So Farouz, you want to take over the screen or you're fine?
Because as you said, we are running out of time. I guess if we all listen to your explanation, since the angle is pi over 3,
Right.
Your explanation would benefit all of us, me included.
Thank you. So let me give you a couple of minutes just to work this out, right? You're gonna draw another, mirror image of the current one along the blue, right? So you start to realize it gets a little bit repetitive, right? But you really need to make sure your algebra is right. You know how to do the algebra, okay? I actually talked to a couple professors the other day who are teaching calculus, and they wish their students are better prepared algebraically. They do. Okay, so that's what we're working hard to do. Okay, to be stronger in mathematics, in algebra operation. If you don't have adequate algebra, doing calculus is like, it's probably a nightmare. Okay, it's probably a nightmare. Okay, but anyway, so we will get this point. What will be that point? You go through that setup, right? You go through that setup, right? So you have x squared, which is red, plus y squared. Okay, this is more like a Farouz way to do it, right? And x is a half, right? Because it's a unilateral triangle. So this is half. Oops, sorry. So this is a half. Okay, this is a half. Okay. And then you end up with y squared equals to 3/4. Right? So everything is similar to the other situation. So in the end, what do we get? We get absolute value of y. Okay, I skipped a step, but this step is okay to skip. Okay, so that's going to be √3/2. Okay, and then what you say? Because Because of what? The angle terminates in quadrant 4, right? That means y is negative. And the absolute value of a negative number is its opposite. So that equals to √3/2. This is a bulletproof. Okay. I know it's gonna, you know, you're not quite used to it. I knew. Okay. I think we're about to close this. So y equals to negative √3/2. Okay, so x is half, right? We knew x is half. We recognize that already from the establishment of the triangle. And then, you know, if you compare with this, all the situations are covered, right? All the situations are covered. And in a lot of cases, in academia circumstances, right? Under academia circumstances, those professors, they prefer these special angles. But in real life, right, you have to be able to do, if they're not a special angle, like what presented in quiz number 10, and also the examples I did in class, is you have to be able to do it in all cases, right? So special angle is really just very academic. For good reason, right? Because other values is not going to be, it's going to be worse, going to be decimal, you know, many digits and so on and so forth. So when you present your answer to the professor, you want to use these numbers. And your professor love to see them. Your professors love to see them. Got it? All right, so that's the, I hope that helps you to understand this. For those of you who had a trigonometry, this will be a review. And for those of you who did not have trigonometry, that will bring you the digital age of geometry. Okay, the digital age of geometry, which happened hundreds of years ago. But because you were born later, right? You were born after, you know, way after I was born. Therefore, you have to catch up, right? We had to catch up. So now with this said and done, you can see, if you go back to watch the past lectures again, what do you realize? You will realize how important this is, because the simplicity of the numbers, right? For different rates, for different trig functions, then you get to get numbers, even though they're not as neat as integer, right? But they're still better numbers. Do you not have to move the square root to the top of the fraction with
I guess rationalizing, I guess it means rationalizing it.
Do you not have to move the square root to the top of the fraction? That's an interesting perspective, huh? That's an interesting perspective. What do you think I've done from here to there? These two numbers are the same numerically. So what's been done here, we just merely rationalize that number. We multiply by 1 using principle number 1. And then the 1 is rewritten as √2/2. Okay, so the √2 times √2, we get 2. 1 times √2 is √2. So I don't know what you mean by moving this to the top. Why do you? No, you don't move it. You don't move anything without a reason. We multiply by 1 to rationalize it. To memorize that moving thing, it's going to get you seriously confused. Are you guys with me? I don't know if did I answer your question, did I answer your question, Harrison? I didn't move anything. I just rationalize it. I didn't move anything. I just rationalize it. How are you supposed to move those? Would I prefer either one? Would I prefer either one? Either one is good. But the key is your professors, you know, other than me, okay, and they're also like me, they want to see exact value. Remember that word, exact value. I already give you the example, right? If you say, oh, the answer is 1/3, I'm going to give you the answer 0.333. Guess what? 0.33333 is not exact value to substitute 1/3. Do you follow me? You better use 1/3. You better use 1/3. If it's being asked for exact value, period. Okay, so you need to have those number senses. You need to have those number senses, okay? Very good question, okay? I'm sure that question is not his question alone. All right, guys, I think you guys need to seriously review trigonometry, right? We're done with the first 6 questions and we have 4 more functions to go. Okay, we're gonna do 3 of the 4, which are the inverse function. We're gonna do next week. Quiz number 11 and quiz number 12 are available soon. Well, quiz number 11 is already available. Quiz number 12 will be available soon, later today. So check it and plan your time and next week. But before next week, I want to show you, you should not wait for me to cover materials. If you want to move ahead, yesterday I sent you a screenshot, right? All of these are about how to derive trig formula. That if you follow those steps, it's going to greatly enhance your algebraic skill, okay? I may or may not have time to do it in class, but you have these past recordings available to you. And also I have covered these topics, right? Special triangle and unit circle. Oh, it's here. Duh. No wonder I didn't find the file. Okay, so I'm going to show it to you now. Special triangle, unit circle. Remember, Farouz, I was trying to show that in my class. Okay, so watch this. We summarize today. Special triangle and unit circle. Watch this. The pi over 6, pi over 3, that triangle, right? Look at that, right? Flipped, 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 right? Keep going. The pi over 3 triangle, right? Pi over 4, there. You can see, right? ARD all along the way. Okay, so I found it. I was, okay.
So Professor, you are going to send it to the other class through?
No, it's
email?
available. It's
Oh,
available.
it's available,
It's
yes.
already available. I just have to tell them where.
Okay,
Okay, it's right here. Special triangle and unit circle right here. It's already available. Okay.
so for the other class you were looking for?
Yes, yes, the same.
Very well.
Okay, so right here. And I have discussions about sine, cosine, arc, sine, arc, sine. So you guys could get started just watching them or reading about them. Okay, the blue buttons are recordings, and these are the writings. I wrote them. I wrote those up. Okay, and there's more lectures available because this semester my progress is slightly different arranged. So in my past lectures, arc sine is already covered by week 3. So you have those lectures. If you just look at those title and watch them, you have a head start. You have a head start. Okay. But of course, I'm going to cover the inverse function. I will cover the inverse function in our class. Okay. But just in case you have time, go ahead to study those. Go ahead to study those. Okay. They're all my recordings. And, I do the same thing with slightly different approach because they all have, I do things, I always constantly change my approach. I make adjustment. So even you watch the past recording, they're not exactly the same as what I'm doing today. And so you will benefit from that other perspective as well. Okay, so our time is up. Keep up with your good work and make sure you do your homework, and the quizzes. Quiz number 12 is coming your way. Okay, I'll see you guys on Monday. Have a great weekend.
Thank you, Professor. And
Thank you.
I mentioned one more time on the chat.
Thank you, Vincent. Yes.
Anybody interested today from 3 to 6 Math Study Center, I will be able to help you with the unit circle number, how to, memorize those easily also.
Yeah. Thank you, Farouz. You're awesome.
Thank you, ma'am. Have a nice weekend.
You too. Thank you. Anybody has any questions for me?